And hello, everybody, and welcome back to week 2 of Tech 301 and Discovering Computers using the resource Discovering Computers 2018 Digital Technology, Data, and Devices. Like last week and every other week that's following, we are going to do this in a series of short lectures that you can break up based on your time allotment during the day, or just click on one through the other to finish them up. Okay, so here we are moving to slide 2, the internet. So we begin to discuss the internet and the conversation we started last week, frankly, that the internet is a worldwide collection of networks, and that each of the networks provides the resources for goods and services and information, right? And at the same time, you'll recall that the web are providing those documents, the messaging, the video communications. Those are all documents that are the widely used services that we're talking about, right? So how does the internet work? The internet works really through a packet routing network, right? In accordance with this IP or Internet Protocol, right? Or some other protocol, but we're going to focus on the IPs. We'll learn later that Web Address Protocol uses some sort of HTTP, hypertext markup, but we're going to talk about that later. What is a protocol then? Well, protocol is just a set of rules that specify how computers should communicate with each other. And so these rules become part and parcel to making one machine understand what the other machine is trying to say. Then you'll ask me, what's a packet? Well, packet is that data, whether it's an email, whether it's an instant message, whether it's a video. It's all just data. It's information, right? Remember, we said information was something that had meaning last week in week 1. So a packet has this information in the form of data, and we send that across the internet, and that's called a message. The message is sent, and it's split up into tiny little fragments called packets. And these packets are sent really independently of each other, and the typical maximum packet size is 1,000 to 3,000 characters, right? And these internet protocols are going to specify how it's packaged or packetized so that the other end can understand it, okay? So then we want to talk, continuing, where did this all begin? Well, the internet began, it had its roots in the Department of Defense. And they have a group called, in the Pentagon, called the Advanced Research Project Agency, or ARPA. And so what they did was they created an ARPA net, right? This first network. And it consisted really of 4 main computers at the University of California in LA, known as UCLA, University of California at Santa Barbara, the Stanford Research Institute, and the University of Utah. And I've kind of put a map down there to show you where those are at. So each site had a host computer, and a host is still part of that common language that we use in computing. So each site here in this first ever internet had a host computer or device, and it provides services or connections to other computers. So as we remember from chapter 1, a web server is an example of a host. Today, a host is a computer or some other device connected to a computer network. And that's really what they started out with, just 4 hosts. And the host may work as a server offering information or services or applications to either individual users, like the client, we call them, or hosts, other hosts, like other servers on the network, right? And a computer participating in these networks uses the Internet Protocol that may be called an IP host. Okay, very interesting. So then, from ARPA to today, there are almost 5 billion people, active Internet users as of April of 2020. Really, almost 60% of the global population has access to the internet. And China, India, and the United States rank ahead of all other countries in terms of internet use, right? So you have to wonder, and really this is for another class, whether our environment is conducive to a healthy, physically active lifestyle that our parents, grandparents, and other relatives grew up with. But that's for another class, like I said, all right? In fact, computers of transition changed so much that when I bought my first home computer in 1991, it had 2 meg hard drive and 2 meg of RAM, random access memory. And that's where, you upload the software, the program that you've opened up, it goes into RAM, and that's how it manipulates things very quickly. And the salesman said to me, that's the last computer you'll ever need. It has so much hard drive space, so much RAM, which is a joke today. My phone has, 500 times that today and needs every bit of it. It's just kind of interesting. So then those were wired connections. Now we introduce, with wired connections, that we have this, a computer or device that physically attaches via some cable or wire to this communications device, right? And so if you have a computer without communications device, they can use wireless modem or some other device that enables this connectivity, but in a wireless fashion, right? So wireless modem would be an example. It uses wireless communications technology such as cellular radio or satellite or even Wi-Fi. You'll notice too, on the right-hand side, it looks like a little memory stick. That's a small form of wireless modem known as a dongle, D-O-N-G-L-E. Now, continuing with this wired and wireless approach, right? A wired approach is when you plug into the cable internet service. So the cable person comes out, installs your cable, and plugs the wire into the wall. You're wired, right? If you're a digital subscriber and you've got a DSL line, you're wired, right? And sometimes it's called FTTP, fiber to the premises, right? But you've run an actual wire. Then there's wireless, which Wi-Fi is one form of wireless, and that stands for wireless fidelity. There are other forms of wireless out there. Mobile broadband, fixed wireless, and even satellite services are available, all of them being wireless. When we talk about wired, there are many forms of wires to be aware of, but one is called a coaxial cable. This is your basic internet cable of the past, right? Where there are 2 cables on the same axis, they're insulated, and that's basic computer cabling. It is shielded so that you don't get interference from other electronic capability. Then, nowadays, what really makes the internet super fast is a cable called fiber optics. And fiber optics are glass fibers used, and these optical fibers carry data using light super fast, not subject to the same interference of the old cabling. This is really what makes the internet super fast today. And some of the leading companies like Spectrum, Comcast, they have 1 gig download modems, which are the fastest by a factor of 5 of any peer competitor, because they have spent much of their existence laying the groundwork for their own fiber optic cable, their own infrastructure around the country. Those are just sample cables, not on the exam. I just wanted to show you that, what some of that looked like. Now, still connecting to the internet. So we've been talking about connecting to the internet and this network, right? And a network needs a router, right? So in talking about a router to connect to the internet via the wired means, right? So in this picture, the router, you see a router and it also acts as, on the right-hand side, in the middle of it's a little box, it's called a router, right? It's going to take your wired communications and route them to the right computer or the right server. But notice that in this case, off to the right, it also goes to some laptops that are not connected to the wire. So in this case, not only is your router wired, but your router is also wireless, right? And when your cable person comes in and installs your router, right, you've got a router in your home. It is hooked up to some wires, but it also has the antennas that provide this wireless capability. So it's really a two-in-one feature. You get the router, which is traditional on landlines, on these connected lines, and the wireless capability. So the router acts as a hub that sets up this local area network and manages all the devices and the communications on it. It, in the wireless sense, becomes a wireless access point known as a WAP, wireless access point. And which is part of this device that allows you to connect more devices to the network that aren't wired, right? You could also do it separately and just have a wireless modem, right, for wireless technology that is going to transmit, again, cellular radio or satellite or Wi-Fi signal, some sort of signal it'll be set up. And where did these routers even come from? Well, these routers originated back when we were talking a few slides ago about ARPANET. That was the Pentagon's effort to create the first internet. The routers originated in the 60s as part of the ARPANET project, right? And the military's goal was to a computer network that was decentralized so that the government could access and distribute information out in case of some catastrophic event. So since then, now we have ISPs, or Internet Service Providers, that have added their own routers to this massive network of computers, right? So there's no single owner of any of these routers anymore, but rather there are multiple owners. The government owns some routers, universities own routers. As in the early days, those were the only two that had it. Now, internet service providers like Spectrum, Charter, or AT&T, Verizon, Comcast, Cox Communications, these are ISPs, internet service providers, and they added on to this network of routers with their own. So, frankly, asking who owns the internet is like asking who owns telephone lines. There's really no single entity that owns all of them. There are many entities that own different parts of them. Okay, so I'm going to stop here. Then we'll pick up with part 2, talking about wireless hotspots or Wi-Fi hotspots. See you shortly.